Hello students, welcome to the lecture number 2 of projectile motion. In the previous lecture number 1, which you can find in this playlist and whose description link is given below, I have explained in the previous video all the theoretical concepts associated with the projectile motion. Now in this video we are going to derive all the formulae associated with the projectile motion, which you can see here. Let's go one by one. Before we start the derivations, we look at the formulae that we are going to use to do all the derivations. General formulae for any two-dimensional motion with uniform acceleration means, we have already seen in lecture 1 that the acceleration of the projectile is acceleration due to gravity, which is a constant value. That's why projectile motion is also a uniformly accelerated motion. The acceleration is constant. You know that when acceleration is constant, then we have these three equations of motion. V is equal to u plus at, v square minus u square equal to as, and s is equal to ut plus half at square. These three equations of motion are applicable only if the acceleration is constant. So projectile motion is really a motion with uniform acceleration. Now, you see here that I have written the equations 2 times. The three equations of motion are written 2 times. And here on one side all the subscripts are x. And here all the subscripts are y. What is the difference between them? Vx is equal to ux plus axt and vy is equal to uy plus ayt. Both of them look like the first equation of motion, v is equal to u plus at. Now, in a two-dimensional motion, like here explained in the diagram, let us say the velocity of the particle is u. Then this velocity can have components. Along x direction component ux and along y direction component uy. Similarly, the acceleration of the particle in two dimension can be resolved into two components ax and ay. Now, what we see from this formula is that this vx is the x component of final velocity, ux is the x component of initial velocity, and ax is the x component of acceleration. Similarly here, vy is the final velocity along y direction or y component of final velocity, uy is the y component of initial velocity, this one, and ay is the acceleration along y direction, or it is the y component of acceleration. So according to mechanics, motion in two perpendicular directions are completely independent of each other. That's why we write the equations of motion independently for x direction and independently for y direction. In fact, we should know here that the acceleration which is acting along x direction, it can cause the change only in the x component of velocity. And the y component of acceleration can cause the change in the y component of velocity only. It cannot happen that when acceleration acts along x direction and the velocity changes along the y direction. That is not possible. So motions along x direction and y direction are completely independent of each other. That is why we have three equations separately or independently for x components and three equations of motion for y components. So these are the 6 equations that we are going to use to derive all the formula for projectile motion, because projectile motion is a two-dimensional motion. First derivation we'll do is the time of flight. Time of flight means what? See, the projectile is thrown and it is now going along the curved path and lands here. How much time did it take to reach here is the time of flight. Once again, see the animation. The time taken by this particle from the starting point to the ending point, that total amount of time is called as the time of flight. So the particle is thrown with initial velocity u, making angle theta with the horizontal. Let's start. So first of all, we are making the components of the initial velocity. Along x direction, it will be u cos theta. Along y direction, the component is u sin theta. So I have written here ux is equal to u cos theta, uy is equal to u sin theta. Also, acceleration components along x and y directions are different. You see here, in the lecture video number 1, I explained that acceleration along x direction is 0 because as the projectile moves in the air, the gravitational force is acting only vertically downwards along y-axis only, opposite to y-axis, negative y-axis direction. That is why there is an acceleration only in the y direction, which is minus g, but along horizontal direction there is no force acting on the particle, so there will be no any acceleration. For more details, please refer to the lecture video number 1, whose link is given in the description below. So starting with these 4 initial values, we will now start solving the question. So this is the screenshot of the first video, whose name is Basic Concepts of Projectile Motion. Please find this thumbnail in the playlist and you will know why ax is 0 and why ay is minus g. Let's continue. So now I am taking the third equation of motion for y direction. We just now saw on the previous slide that the 3 equations of motion were written for x-axis and the other 3 equations of motion were written for y-axis. So I am taking the third equation of motion for y-axis only. Here s, this looks like the third equation of motion, s is equal to ut plus half at square, but you can see that this is the component, y component of displacement, y component of initial velocity and y component of the acceleration. Now, what is the y component of displacement as the particle starts from this point and lands on the ground? Let us see. So students, actually the displacement along y direction is 0. You might be surprised to know why it is so. The particle has gone from here to here. Why the displacement along the y direction is 0? So here is the explanation for this. The meaning of displacement is, definition of displacement is final position minus initial position. This is the formula that we study in one-dimensional motion. The displacement is equal to final position minus initial position. Now, since we want to find out the displacement only along the y direction, so displacement along y direction is equal to the final y coordinate minus the initial y coordinate. Now as the particle starts from ground here, initial point, what is the y coordinate? Initial point here 0, because see the y axis, the 0 is here, starting point. Now after the particle has traveled all this path and lands on the ground, again its y coordinate becomes 0. You see, because y coordinate nothing means the height from the x-axis or height from the ground. So starting point, the height is 0 from the ground. After landing also, the height from the ground is 0. Therefore, the final y coordinate is 0 and initial y coordinate is also 0. So 0 minus 0 is 0. That is why even though the projectile has moved from this point to this point, but the displacement along y direction is 0. And uy value you can take from here, u sin theta. T means the time taken. So the time taken from starting point to the ending point, the total time t, I am writing with capital T. Capital T here represents the time of flight, the total time taken. And half into at square. So acceleration along y direction is minus g and into t square, the time taken. Let us solve this equation. So bring this minus half gt square term on the left side. Half gt square is equal to u sin theta into t. Now this t and this square t can be cancelled. So this t is gone and only one t remains this side. And after simplifying, we'll get the answer t is equal to 2u sin theta by g. This 2 gets multiplied here, 2u sin theta, and g comes below the denominator. So the time of flight formula is 2u sin theta by g. Furthermore, you also observe that u sin theta is nothing but uy, so this formula can also be written as 2uy by g. So finally, after solving this question, solving the derivation, we learn from here that the time taken by the projectile to go from the starting point to the ending point, that time of flight depends only on the y component of initial velocity. It does not depend on the x component of initial velocity. Interesting, isn't it? Let's go ahead. Next derivation. Now we will discuss about the maximum height. See here, look at the animation once again. Particles start from ground. And this is the maximum height. As you can see from the ground, this topmost point of the projectile is the maximum height. And if you again read the lecture 1, you will find that at the highest point also the velocity doesn't become 0. The velocity is u cos theta. Along x direction the velocity will be u cos theta, but along the y direction the velocity becomes 0. For more details, you need to read the lecture number 1. Now, This h is the maximum height from the ground, and we want to find what is this height h. So let us see what equation shall we use from our list of those 3 plus 3, 6 equations to get this answer. We will use the second equation of motion. V square minus u square is equal to 2as. But you see the subscripts here is y. That means we are taking only the y components of the velocities and acceleration and displacement. Now here Vy means the final velocity y component, which is 0. At the highest point you see the y component of the velocity becomes 0. So Vy will be put as 0 here. So Vy square means 0 square. Uy is nothing but u sin theta. See here initial velocity y component is u sin theta whole square. And 2 into acceleration along y direction is of course minus g. And what about this displacement along the y direction or y component of displacement is h, the maximum height. Why is it so? Again let us see. As per the definition, displacement is defined as final position minus initial position. Now, so we want to calculate displacement along y direction, which is defined as final y coordinate minus initial y coordinate. Now, as the projectile went from ground to the highest point, this is the final position. What is the y coordinate of this point? So, y coordinate means nothing but the height along the y axis. So, y coordinate is nothing but equal to the h only. Final y coordinate of this point is h. And initial y coordinate starting from origin is 0. So, h minus 0 is h. Therefore, my friends, the displacement along y direction or the y component of displacement is equal to h. So, substitute here h. Now, solve this. Minus minus cancel from both sides. And by simplifying, you will get h is equal to u square sine square theta by 2g. Formula should be remembered. Furthermore, you also notice that u sin theta is nothing but uy. So, can we substitute here uy? Yes, we can write one more formula. Maximum height is equal to uy square divided by 2g. Next derivation. Horizontal range. Now we want to find what is the horizontal range. The meaning of horizontal range is from the starting point to the ending point, how much the particle has moved along horizontal direction. This much distance is called as the horizontal range. You can say the horizontal distance between the landing point and the starting point, that horizontal distance on the ground is called as range or horizontal range. Let us represent by r. Once again, the initial conditions are same. Let us start our derivation. Now this time we are taking the third equation of motion from the first list of formulae. That means along x direction. Sx means displacement along x direction. Or you can say x component of displacement. Ux is the x component of initial velocity. T is the time taken from starting point to the ending point. Ax is the acceleration along x direction, which is 0. So the second part of the right hand side will become 0. Only this much will remain. Let's see, put the values here. Now the displacement along x direction from here to here is, of course, it is equal to the range r. But it can be also understood once again using this definition formula. The displacement is defined as final position minus initial position. Now, if you want to find displacement along x direction, then you should write down x final minus x initial, means final x coordinate minus initial x coordinate. So my friends, see here, when the particle starts from here and lands here, at this point, what is the x coordinate? So from origin along x direction, if you measure this distance, that x coordinate is nothing but the range r, this distance. And what is the initial x coordinate? Of course, it is 0 because particles start from origin. R minus 0 is r. Therefore, this r itself is the displacement along x direction. Ux value is u cos theta, substitute here t. Now the time taken is definitely the time of flight, whose formula we have already derived earlier. And Ax is 0. So now we are substituting here the formula for time of flight t, which is 2u sin theta by g. You can go back to the video once again and see. Just a few minutes ago we have derived this formula. Time of flight is 2u sin theta by g. So now what happens? The u and u gets multiplied, become u square and 2 times of sin theta cos theta. So u square into 2 sin theta cos theta Okay, so u into u square and 2 into sine theta into cos theta. We write in a bracket. And from trigonometry, we know that 2 times of sine theta cos theta is nothing but sine of 2 theta. This is the formula in trigonometry. Sine 2 theta is equal to 2 sine theta cos theta. Hence, this is the formula for the horizontal range, u square sine 2 theta by g. Furthermore, we can also convert this formula in terms of ux and uy like this. So let us take the same formula here, this one. What we derived here till this point, same thing you take it here. Can we write down the same thing as this? 2 into u sine theta u cos theta by g. Look at the number 2 is taken here. U sine theta I writing first and then u cos theta writing later. Divided by g. Now, as you can see in the table, u sine theta is nothing but uy and u cos theta is ux. So basically these two brackets product are this the product of ux and uy. So we can write down that the range R is equal to 2ux into uy by g. Another formula. So that we list here. So two formula. Always we have two formula for each type of case. Okay. So range can be written as u square sine 2 theta by g or equal to 2ux uy by g. You must remember both of them. Sometimes in some questions this second format of the formula is more useful than the first one. Let's go to the next derivation. Maximum range. Rmax. You see, you might have seen in movies that a cannon fires bombs and it has to hit the enemy to the maximum possible distance. Okay, so suppose here is our cannon and here is our enemy and we want to hit it. But sometimes we have to adjust our angle of the cannon or the gun so that the bomb can land at the maximum distance. Now let us see let's do one thing. Let us say we first throw the bomb at some small angle and it lands here. It didn't reach here. What we can do that we can again increase the angle, little bit increase the angle. So now the projectile can land here. Again increase the angle. Maybe then in that case it will reach here. So as you keep on increasing the angle of projection, see these are not same angles. The first one was thrown at small angle, next one little bit higher angle, next one also again higher angle. So and maintaining the same speed, you are maintaining the same initial speed u, we throw the projectile at different angles. See, like in case of a tank or a cannon or a gun, the velocity with which the bullet or the bomb comes out, that cannot be changed, that will remain same only. We can only adjust the angle. So by increasing the angle, we find that the range is also increasing. But will it keep on increasing continuously if you keep on increasing the angle? Let us say if we again increase the angle. Right, so that was the Rmax maximum. But if you suppose increase the angle, see the increased angle. Now what will happen? That the bomb will come back actually. It will have lesser range. And even more higher angle, it will land here. In fact, if you make the angle equal to 90 degree, the bomb will go straight vertically up and it will come back at the same place. That would be dangerous. So what we observe from this analysis, we can observe this analysis once again, okay? That as we keep increasing the angle of projection, maintaining the same speed, the range is first increasing, and then after that, if we furthermore increase the angle of projection, the range begins to decrease. Now, therefore, it means there exists some angle in between. In between, there is some angle at which we obtain the maximum range. Let us see what is that angle at which the range can be maximum maintaining same speed. So starting with the formula that we have just derived on the previous slide, that range is u square sine 2 theta by g. By looking at this formula, can we say that the range is directly proportional to sine 2 theta? Because we cannot change the speed. Speed will remain same only. G will also remain constant same. What is in our control is only the angle theta. We can control the angle theta by raising the gun up or down. So we can say that range R will be maximum when the value sine 2 theta is maximum, right? Range proportional to sine 2 theta. So what is the maximum value of sine 2 theta? Let's see. According to trigonometry, the maximum value of any sine or cosine function is plus 1. In whatever is the thing, whatever function, sine and cos function always maximum value is plus 1 only. Therefore, sine 2 theta should be made equal to 1. But we also know that sine 90 degree is equal to 1. Therefore, this angle 2 theta should be 90 degree. Therefore, the angle theta is 45 degrees. So here is the answer. You see, if you throw the bomb with the same speed u but angle 45 degree, then in that case we will obtain the maximum range. And then what will be the value of this range? Let us see, substitute this value theta 45 degree here into this formula, or you substitute 2 theta is equal to 90 degree, or you just write down sine 2 theta is 1 here. So we will get Rmax is equal to u square by g. So let's go to next derivation. Same range at two different angles. Now this interesting fact was said by Galileo. Galileo said that if you have a gun or a cannon, you can obtain the same range at two different angles. As we saw in the previous slide, that when we keep on increasing the angle, then firstly the range increases and then again it decreases. So it is possible that we can obtain the same horizontal range at two different angles. So here we have shown that at two different angles alpha and beta, the projectile was thrown with the same speed u, but at different angles alpha beta. So at smaller angle beta we get this much range, at larger angle alpha also we get the same range, but you see heights are different here, but range obtained is equal. R alpha is equal to R beta. So let us start our analysis and find out that what could be the condition or what could be the relation between these two angles so that the ranges are equal even at different angles. So using the formula for the range we have derived just now, u square sine 2 theta by g, we will substitute here. For angle alpha, the range will be u square sine 2 alpha by g, and for the angle beta, the range will be u square sine 2 beta by g, and we want them to be equal. So we made them equal. Now u square cancel, g and g cancel. So what we obtain now is only sine 2 alpha is equal to sine 2 beta. Now, of course, one of the solution of this trigonometric equation is that alpha is equal to beta. But we don't want that. We want the solution to be different. So what we do here, we apply a important formula here. You see, sine 2 beta can be written as sine 180 minus 2 beta. Please refer to your trigonometry textbook. You will find out that sine of 180 minus theta is equal to sine theta. So sine of 180 minus 2 beta is also equal to sine 2 beta. So we are just replacing one of them. Sine 2 beta is sine 180 minus 2 beta. Now we can say, okay, by comparing LHS and RHS, that 2 alpha should be equal to 180 minus 2 beta. So 2 alpha is equal to 180 minus 2 beta. Then bring this minus 2 beta to left side. We'll get 2 alpha plus 2 beta is equal to 180 degree. Now dividing the entire equation by 2, we'll get alpha plus beta is equal to 90 degree. So this is the final answer. That these two angles, alpha and beta, should be complementary angles. That means if you take two different angles, for example, let us say first angle you take 30 degree, then the second angle should be 60 degree. So therefore, if you use the same gun at angles 30 degree and 60 degree, you will get the same horizontal range. Or maybe let us say first angle is 20 degree, then the second angle should be 70 degree. Any two angles combination whose sum is 90 degree will give you the same horizontal range. We can also represent answer like this. Suppose angle alpha is theta, then angle beta should be 90 minus theta, because their total sum must be equal to 90 degree. Or another way of writing it is, this is what said by Galileo in his book, that if suppose one angle is 45 degree minus theta and other angle is 45 degree plus theta, then we will obtain the same range. You can check that the sum of alpha plus beta is again 90 degree only. So add both of this, minus theta plus theta get cancelled, becomes 0, and 45 plus 45, 90. Hence we should remember that if you want to obtain the same range at two different angles, then those two angles must be complementary angles, or the sum of the angles should be 90 degree. Let's go to the next derivation. Yes, x and y coordinates at any time t. See, the projectile was thrown from the ground here, and as it is moving, you can see that its x coordinate is changing, isn't it? Though the particle is moving along this curved path, but its x coordinate is increasing along this x direction. Similarly, its y coordinate is the first increasing and then maybe again coming back to here, right? So if you understand the coordinate system properly, then you can see that if you suppose any point on this curved path, if you take here t, and the coordinates of that point is x comma y, what it means is that from the origin, the distance of that point along x direction is equal to x, that is the x coordinate meaning of this point, and the height of that point from the origin is equal to y, that's called y coordinate. So this is the meaning of x and y coordinates. Let us take any point on this parabolic path. Parabola, will prove it later. It's, yes, of course, it's a parabolic path, the curved path is parabola, but we prove it in the next slide. So take any point on the path, let us say, whose coordinates is x and y. The meaning of x and y explained here. From the origin, the distance of that point along x direction is x, and the distance of that point along the y axis is equal to y. Now at t is equal to 0, the particle starts from the ground, and after time t it reaches this point. Okay, we want to find what is the x coordinate after time t. So the particle has taken t amount of time to go from here to here. Once again, you see the animation. Particle start from the ground at t is equal to 0, and at t is equal to t second, after t second it comes here. Please note that I am not writing capital T here, because capital T would mean that it will land here, total time of flight. We are taking any general time t which is lesser than the time of flight. Let's start now. How to find the x coordinate? Actually, we can observe from this analysis that this x coordinate is nothing but the x component of displacement of the particle. Therefore, we must use this formula for x component of displacement. Third equation of motion, Sx is equal to uxt plus half axt square. Let us substitute the values. Definitely, the displacement along x direction is this x coordinate x. Ux, we know here is ux, u cos theta, time taken t, small t only, and plus the acceleration along x direction is 0. We know that in the projectile motion, horizontal acceleration is 0. Therefore, we obtain our first result that x coordinate at any time t is u cos theta into t. Similarly, take the third equation of motion for y direction. Sy is equal to uyt plus half ayt square. Then what is the displacement along y direction? It is nothing but the y coordinate of that part. Y coordinate is equal to, substitute the value, uy is u sin theta, here is uy, initial velocity along y direction, u sin theta, time taken t, and ay is minus g. Yes, we have seen in the previous slide, ay is minus g, minus half gt square. So these are the two equations, x and y coordinates of the particle at any time t. So using this formula, you can find out not only the location of, you can find out the location of the particle anywhere on this path, anywhere you want. Finally, the final derivation is equation of trajectory. Trajectory means the path. This curved path, as you see here, is called as trajectory. So as the particle goes along this path, we are trying to find out the equation of trajectory. So just now on the previous page, we have derived this formula, x is equal to u cos theta t. This is the x coordinate of the particle at any time t. Then we also derived this y coordinate of the particle at any time t. These two equations I am taking from the previous page only. Now what I am going to do from this is, see here. From the first equation, let us calculate the value time t. T is equal to this u cos theta, divide here, x by u cos theta. And then this value time t, you substitute into this second equation, in here and here. Let's see what we get. So y is equal to u sin theta as it is, the time t value x by u cos theta substitute here, and minus half g, and this is square, t square means x square by u square cos square theta substituted here. So now you cancel this u and u, sin theta by cos theta become tan theta. So here the final answer, y is equal to x tan theta minus gx square divided by 2u square cos square theta. This equation is called as the equation of trajectory, because it is the relationship between y coordinate and x coordinate of the particle, and the time t is not present here. You can see we have eliminated the time t from both the equations to obtain this result. So a relation between y coordinate and x coordinate of the particle is called as the equation of trajectory. Now this equation is quite a big equation, and every student is supposed to memorize this formula. And now this is equation of parabola. According to maths, this is a parabolic equation, and so this path is a parabola. Why is it parabola? Let us see. Look at some maths of parabola. According to mathematics, any equation which is y is equal to ax square plus bx plus c. You might recognize this is the quadratic equation. Y is equal to ax square plus bx plus c. Such kind of equation is called as a equation of parabola. That means when the y coordinate is proportional to the x square of x, then it is parabola. Two more important points to be noted here regarding this parabolic equation, that this a, which is the coefficient of x square, if the coefficient of x square is a positive number, then the parabola will be an upward parabola drawn like this. And if the coefficient of x square is negative value, then the parabola would be downward parabola. Now compare this with this equation here, where we can find ax square. Here is our ax square term. So what is the constant a here? A is minus g divided by 2u square cos square theta. That much is the constant a. But there is a minus sign before x square term. You can see here, minus sign before x square term means the parabola should be downward. That is why the projectile motion is a downward parabola. The shape of this projectile is downward parabola. And of course, it is only under the case when air resistance is neglected. In all the derivations, air resistance is neglected. And second term bx we can also find here. Bx, this is b is the tan theta x. And c is 0 here actually in this case. What is the meaning of c? Then nothing but the y-intercept. Y-intercept means where this curve cutting the y-axis. So it's cutting at 0 only. That is why c is equal to 0. So this equation matches with the standard format of the equation of parabola in maths. Now, one more simple derivation, that this equation of trajectory, second part, that equation can also be written in one more very useful format. So starting with this previous derivation, let's do some more analytics on this. So what we do that from this equation, this x tan theta take common from both the terms. Okay, take common from both the terms. So you take common, put a bracket here, and so from the first term if you take common, then it becomes 1 minus, and from the second term when you take it common, you put it in the denominator. Why is it so? Because see, taking common always means division. When we take anything common, it means we are dividing it. So when we take x tan theta common from both of them, then the first term x tan theta get divided by x tan theta, so we get 1, and the second term also get divided by x tan theta. Students, you should understand that the meaning of in mathematics, that taking something common means you divide it by that same term. So when x tan theta has been taken out of the bracket common, it means every term inside the bracket you divide by the same x tan theta. So you divide this first term x tan theta by x tan theta, you get 1, and the second term also divide by x tan theta. That's the meaning of taking common. Let's simplify further. Now here you see, this x will cancel x square, and only one x remains in the numerator, and this x will gone, and tan theta can be written as sin theta by cos theta, and this cos theta will cancel the cos square theta, and only one cos theta will remain here. So we'll get gx upon 2u square. So this cos theta cancel cos square theta, only one cos theta and sin theta, so we get sin theta cos theta. Now can you see that there is something here, 2 times of sin theta into cos theta? And we know from mathematics that 2 times of sin theta cos theta is sin 2 theta. So in the next step, we are replacing these 2 sin theta cos theta as sin of 2 theta. Finally, in the last step, let us take this g from the numerator and bring it below here. If you come below this u square sin 2 theta. And now if you recall, u square sin 2 theta by g is the formula for the horizontal range. Therefore, replacing it with horizontal range, we get a nice looking formula. Y is equal to x tan theta in the bracket 1 minus x by r. This is another very useful formula for the equation of trajectory. So I'm calling part 2. So these are the two different formulae for equation of trajectory. In some questions, the first formula will be useful. In some questions, the second formula will be useful. So after this, so this is the end of this lecture video, and in the third lecture, I'm going to discuss some more derivations, some higher level derivations which are suitable for JEE Mains and JEE Advanced, and also I'm going to discuss in the fourth lecture, numerical problems based on all these formulae that we have derived here. So please pay attention and also go to the next lectures. Thank you very much for watching my video. and I hope that you have enjoyed learning the concepts of physics. Please like the video and also please subscribe. Here is my YouTube channel. Please go through my channel. There are lots of videos related to different topics which you'll really find helpful, and please write in the comments what all different types of concepts and questions you want me to discuss with you. I'll be happy to reply to you. Thank you.